So, well, I'll assume that we don't know what pyramid is. We don't know. So, see, the triangle OPQ so consider the triangle OPQ. Or let's have this. So this is usually the x-axis. And this point is home. So this is Q. This is P. So this is 90 degrees. All this angle theta. Make that fit. So then I want us to call this radius, this distance R. And then this distance OQ, let's call it X. And let this side be Y. So then now, we know this acronym. Oshachote is a familiar acronym. Some call it Okatoa, but I call it Oshachote. So, so these are the main letters in this acronym. So where it means sine, so sine is opposite of hypotenuse. This cosine adjacent of hypotenuse, and T is tangent opposite of adjacent. So we have the following 6 trigonometric functions. So first one is called cosine. We abbreviate by cos. There's another one we call sine. We abbreviate by sin. Another trigonometric function is tangent. We abbreviate by tan. And then, when you get the reciprocals of this base trigonometric functions, you get there's another one we call secant, which you abbreviate by sec. And sec is given by 1 over cosine. Second, and then this cosecant. So this we abbreviate by this. This is the reciprocal of sine, and then this cotangent. So abbreviate this one by cot, and this is 1 over tangent. So these are the basic 6 trigonometric ratios of functions. So then now from Oshachuta, we can actually define with respect to this angle theta, these 6 trigonometric functions. So cos theta. So cosine is adjacent of hypotenuse. So with respect to this triangle, I'll have adjacent is x, hypotenuse is r. So which means X is the next X is R cos theta. So call it one. So call this relation one. And then sine is opposite of hypotenuse. So with respect to this theta, opposite is y, hypotenuse is r, which we can also make y. So have r y equals to r sine theta. Call it 2. Then we can define tan. So tan is opposite of adjacent. So opposite is y, adjacent is x. So now, from the first equation, I can square both sides and I have x squared is given by r squared cos squared theta. That's from equation 1. And then when you square these two, we'll have y squared is r squared sine squared theta. Then these two, we can add them so that we have x squared plus y squared will give us r squared into cos squared theta plus sine squared theta. But in the same triangle, we did a right angle triangle because of this basis 90. So x squared plus y squared is r squared. 1. Is x squared r squared? Here. I don't know. Why is x from this one? That's one. So this is by Pythagorean theorem. So then now, we are free to replace by x. So which means then from this line here, this is the same as having r squared equals to r squared into cos squared theta plus sine squared theta. Then you can divide through by r because r is non-zero, so which means that cos squared theta plus sine squared theta is equals to 1. These are very powerful identity that is going to help us solve the problem on trigonometry. Call it 3. Give name to that. Now, I remember we have this triangle. This is theta, this is x, this is y, this is r. And then you have said that cos of theta is the same as adjacent of hypotenuse. Sine of theta is given by opposite of hypotenuse. Tan of theta is given by opposite of adjacent. And then by the way, you can define sec theta are the reciprocal of this, so r over x, and then cosec theta is the reciprocal of sine, so r over y, cot theta is x over y. So these three being new, we can just put in brackets sec theta means 1 over cos theta. Then cosec theta means 1 over sine theta. And cot theta means 1 over tan theta. So these are the ratios of functions based on this 19. So if I say sine theta divided by cos theta, then is y over r divided by x over r, which is y over r times r over x, and this is y over x. And what is y over x? Please, I want us to move together. What you are doing is very basic. You have to give a basic time. Start doing anything. There's no limit here. This is basic class 1. So x, y, like tan. So this is tangent. So then, tan is the same as sine over cos. And if you do the other way around, cos over sine, so we'll have cos is x over r divided by sine is y over r, which is x over r times r over y. And this you get x over y. X over y is cot. So this is cot theta. I want to know obvious to you that if you did say ratio of cos over sine is cot, ratio of sine over cos is tan. So from 3, if I decide to divide this by cos squared theta, then I'll have 1 plus sine squared theta over cos squared theta equals to 1 over cos squared theta. Then sine squared over cos squared is tan squared. Okay? Tan squared theta. 1 over cos sec. So sec squared theta. This is another very powerful tool that can call it for. So that's another identity that can also help with problems. And then also from this Pythagorean relationship, you can also divide two by. So we'll have cos squared theta over sine squared theta plus 1 equals to 1 over sine squared theta. So cos over sine, cot. So cot squared theta plus 1 is sec squared theta. So you can add that to your toolbox. Let's say call this one, say facts. So from then having cost of assignment given by these two respectively, you can also generate other that relation. So double angle. Because of time, I'll state without proof the double angle formulas. So one, sine of A plus B is sine of A cos of B plus sine of has to be consistent. Plus cos of A sine of B, then sine of A minus B is sine of A cos of B minus cos of A sine of B, and then cos of A plus B is cos of A cos of B minus sine of A sine of B, and then cos of A minus B is cos of A cos of B. Now this minus this becomes plus sine of A sine of B. Then tan of A plus B is tan of A plus tan of B divided by 1 minus tan of A tan of B, and then distance tan of A minus B is tan of A minus tan of B divided by 1 plus tan of A tan of B. So these are the please write these formulas. We want to use them to generate other more relations. So proof of these formulas is not even in the application of the problem, but all the proofs are there. Y say cosine of A plus B plus cos A sin B. What matters is how to apply how them to generate other relations. Done? Okay, good. So then now, having known these base formulas, I want us to say if we were to add one, so formula 1 plus 2 add, I have sine A plus B plus sine of A minus B. So give us for the 2 sine A B, because you say these two are the same, so plus minus cancels out. Okay? Yeah, just have 2 sine A cos B. So 2 sine A cos B. So you can also add this to your toolbox. This is another relation. So maybe we call it 7. And then 1 minus 2. So I want us to start 2 from 1. So I'll have sine of A plus B minus sine of A minus B. So what do you get? Right? 2 now, 2 cos A sine B, okay? So 2 cos A sine B. You can call this one 8. This is another relation. And you can perform the same thing for 3 and 4. So 3 plus 4 will have cos A plus B plus cos A minus B. So that will give us, when you add 3 and 4, 2 cos A, well, these are the two terms we cancel out. So I'll have 2 cos A cos B. Maybe call that one 9. And then we do the same thing. Say 3 minus 4. We'll have cos A plus B minus cos A minus B. So there we get the negative. I get it. 2 sine A sine B. So if you're a man who doesn't like having negatives, then we can actually remove this negative and say it's the same thing as having cos A minus B and then minus cos A plus B is twice sine A sine B. So that's the same formula. So this and this mean the same. Or okay. So let's check this equation, this formula. Sine A plus B sine A minus B, 2 sine A plus B. So I want us to fix this to be one number, this to be another number. So let's say theta be A plus B and phi be given by A minus B. Okay. Theta be A plus B, phi be A minus B. So by doing that, we want to control 7 such that here I have sine of one quantity, this sine of another quantity. Similar to this formula, 8, 7, this will be formula 8, 7, 8, 9, and 10. So can you solve for me the value of what is A And what is B? So solve these two equations simultaneously and tell me A in terms of theta and phi, B. So A will be. So you can actually A in terms of theta and phi. Okay. Yeah. Yes. So A will be theta. Yes, theta. A equals to plus. Just theta plus phi. Next what do you have? Okay, so these are very easy. So the easiest way to solve for A, just add the two equations. If you say one, this plus this will not have B, okay? So we'll have theta plus phi equals to 2A. So then you divide through by 2, okay? Yeah. So we'll have theta plus phi. Theta plus phi from the other side. So A will be theta plus phi divided by 2, and B. So to eliminate A from those equations, you subtract, okay? So the equation, if you call this equation one, these two, 1 minus 2 will be theta minus phi divided by, or I'll have the two of them, okay? Yeah, divided by 2. So which means then now, from 7 to 10, there'll be no mistake by us replacing theta plus phi over 2 for A and theta minus phi over 2 for B. So therefore, formula 7 will be formula 7. Please allow me to run this part. So then now, with that in mind, then we can rewrite 7 as sine theta plus this is sine phi is equals to twice sine of A is theta plus phi divided by 2, and then cosine B is theta minus phi divided by 2. Or I can say sine theta plus phi over 2 cosine of theta minus phi over 2 is nothing but a half into sine theta plus sine phi. So then another that can help with the product or a sum of two trigonometric functions will be a sum of product. So then now, similarly now 8 becomes sine theta minus sine phi is equal to twice cos theta plus phi divided by 2, and then sine theta minus phi divided by 2. So that's another formula. Then they can put them in brackets to show, right? So that you can express sum of two different angles as a product of sine and cos. Then you can express the difference of two sines of two different angles as a product of sine and cos. And then similarly, we can do the same substitution here. We'll have cos of theta, cos A plus B theta, plus cos of phi is equals to twice cos theta plus phi divided by 2, and then cos theta plus theta minus phi divided by 2. So this is another relation. Then from this other one, we have cos theta minus cos phi is minus 2 sine theta plus phi over 2, and then sine theta minus phi divided by 2. So add this to your toolbox. These are them. Okay, 11, 12, 13, 14. So that's another relation where you can be asked to express sum of difference terms of product. So this is how these quantities are related. Please know that you are thin enough to understand that this, when I started by picking my angles to be A and B, and here now express A and B in terms of different other variables, theta and phi. These quantities A, B, theta, and phi, and to mean that any letter can actually be used to write the same thing. So for instance, where someone else can write the same formulas by still using A and B, the place of theta, provided in the same fashion. So this is a different concept. So you can have the same 11, 12, 13, 14. You can, where there's theta, you can simply use the variable A. Where there's phi, you can use the variable. Really simple. Just like when we say that cos squared theta plus sin squared theta is 1, is not different from saying cos squared A plus sin squared A is still 1. So, yeah. So don't fix your mind that they must say theta and phi for you to write the formula. You can use different ways, even x and y. Then As an appetizer, express each of the following. Express each of the following as a sum difference. Express each of the following as a sum or difference. 1 sine 40 degrees cos 30 degrees. And then 2, we have cos 110 degrees sine 55 degrees. So express those quantities in terms of either sum or difference, depends on how, when you have cosine and sine cos, what should happen. Can you try that? So to try that, so this is a solution. So what is sine A cos B? From the formula, 11. If I give you sine A cos B, what is the expression for that in terms of sum or difference? Sine A cos B. I hope you have not forgotten what I've told you. What I've told you. That's the formulas we have written 11 to 13, 11 to 14. You get the same formulas by letting theta to be a variable, say A or X, letting phi to be variable B or Y. So this one, the expression you want, I expect you to tell me is obtained from number 11 to 14. One of them is the correct answer. So this will give us sine A cos B. Sine A cos B. What be? Sine A cos B. Okay. Now, tell me, we have this formula, sine A plus B. If I say plus sine A minus B, what is the answer? Let's check the start. When you introduce double angle formula 10, after writing 1 to 4 and 2 to 5, then we had this, we added equation for A plus B and equation for sine A minus B. What is the answer? 2 sine A cosine B. Okay. So do you need the answer for sine A cos B? Just remove this two. Okay. Yeah. So to get the value of sine A cos B, divide through by 2, divide through by 2, or multiply by a half. So then sine A cos B is nothing but a half of sine of A plus B plus sine of A minus B. So when we give you the expressions for the double angle formulas, and you have the identity for cos squared theta plus sine squared theta equals to 1, then you can always derive on other those base formulas. So this is what you have. This is the expression for sine A cos B. So what is our A in this case? In problem, remember now, this question sine 14 cos 30 is taking this structure. Sine of an angle times cos of another. So our A is which value? If now we relate the formula to what you have to solve. A is 40 degrees. And what is B? 30 degrees. So therefore, this means sine 40 degrees cos 30 degrees will be a half into sine. So where there's A, you put 40, where there's B, you put 30. So 40 plus 30 plus sine 40 minus 30. So 40 plus 30, 70. 40 minus 30 is 10. So therefore, the answer is a half into sine of 70 degrees plus sine of 10 degrees. This is not an Olympiad problem. We are just starting new introduction. So this one. Then the other one we have sine. So we have what is the expression for cos A sine B. And I hope you will actually. So here we are. Yeah. So when you subtract, you get. So the A sine A plus B minus sine A minus B gives you. Just take a book. Not time for suffering. A time will come immediately. So you should not suffer this time. So what did we get? When we get the difference? 2 cos A sine B, okay? Then you just make cos A sine B the subject. So the same thing as dividing through by 2 or multiplying by a half. So that's what you have. So therefore, what we need is cosine of A sine of B is given by a half into sine A plus B minus sine of A minus B. What is our A difference? A is 110, B 55. So I'll have what is given will be a half. So the answer will be a half into sine of 110 plus 55, then minus sine of 110 minus 55. So the final expression will be a half into sine of 165 minus sine of 55. Remember, this is the final answer. You wanted just us to express as the difference of sum. So the first one is what is giving us a sum. This is a difference. This is this expression that both require. Now, this one now you have to tell me the answer because I'm giving you the start. So the next one is express each of the following. Express each of the following as a product. Express each of the following as a product. Express each of the following as a product. So the first one is sine of 50 degrees plus sine of 40 degrees. And then the second one is sine of 70 degrees. Then minus sine of 20 degrees. So from what we have derived, I want you to tell me what is the value of A plus sine B. A plus sine B. So they are in the formulas we derived, so it's from number 11. And just remember the role of theta now can be taken by A, phi taken by B. So the formula will be okay. So just check from number 11, 13, 14. Then the role of theta take it by B. Then you should be able to get expression. So it'll be 2. Then 2. Next one. Sine of A plus B over 2 multiplied by cosine of A minus B over 2. So I've told you that those variables we're using are dummy, which means that you can use any other variable. So when you're deriving this formula here, this was theta, this was phi, but you can also express it in any other different form. So this is the definition. So A in this case is 50, then B is 40. So this implies that sine 50 degrees plus sine 40 degrees will be 2 sine of 50 plus 40 divided by 2 multiplied by cosine of 50 minus 40 divided by 2. So this will be 2 sine of which angle? Two sine a half of 50 plus 40, 45. Then cosine of 5 degrees. Now, can you now tell me the other two? The second one. Tell me the other. Then the appropriate formula for sine A minus sine B. So once you have that one correct, then you should be able to get the product. So what's the formula here by this? Will be twice sine A minus sine B. Will be 2 cos A plus B divided by 2 multiplied by sine A minus B divided by 2. So replace accordingly and tell me the final. When you substitute, your answer will be 2. 2 cos 45 sine 45. Good. So 2 cos 45 degrees, and then sine 20. Right. Because remember, A is 70, B is 20. So 70 minus 20 is 50 divided by 225. And then 70 plus 20, 90 divided by 2. Now, before I move away from this double angles formula, so we are saying that cosine of A plus B is cosine of A, cosine of B, minus sine of A, sine of B. We have this relation. So I want us to see how we the same relation when A equals to B. So when A equals to B, we'll have cos A plus A will be cos A minus sine A sine A. Because the value will be the same as the value. So A plus A, 2A. So cos of 2A is cos squared A minus sine squared A. Add this to your toolbox. That cosine of 2A is the same as cos squared A minus sine squared A. So having known that, but we know that cos squared A can be written as 1 minus sine squared A. So you can increase cos squared for that unity in terms of sine. So which means then this can be written as cos 2A is, instead of this, I write 1 minus sine squared A minus sine squared A. So this is 1 minus 2 sine squared A. So which tells me that another way of writing sine squared A, if I take this to this minus sine squared A to the left, be plus, so I'll have 1 minus cos 2A divided by 2. So this is another way of having sine squared A can be expressed in terms of cos 2A. Similarly, you know that sine squared A is 1 minus cos squared A. So which tells me that from this section, cos 2A, where there's sine squared, I can replace by expression of cos. So this will be cos 2A is the same as cos squared A minus the place of sine, I put 1 minus cos squared A. So which tells me that cos 2A, when I open brackets, If I open brackets, yeah. Index one. I open brackets. Collect item. 2 cos squared A minus 1. Okay. So which tells us that cos squared A is nothing but make this a subject. So I'll have 1 plus cos 2A divided by 2. Add this to your toolbox. So this is another identity that can help you to find problem. So add that to your toolbox. Okay. Also, we say that sine A plus B is sine A cos B plus cos A sine B. Please, you need not derivation of these things I'm telling you to add on toolbox. What you have to remember, the key thing is to remember double angle formulas and obvious Pythagorean relationship of cosine. Then we'll be able to get these relationships. So when we let A to be B, so then this will be sine A plus A equals to sine A cos A plus cos A sine A. That's what it is. So when A and B, so right hand side is the same equation. So sine A. So remember, X and Y is the same. So this implies sine 2A is the same as 2 sine A cos A. Add this to your toolbox. So sometimes you may have product of sine and cosine at the same angle, and this may be very useful to reduce the expression. So we now let's remember some form 2. So this is form 2. So consider this triangle and this triangle A, B, C. Consider an equilateral triangle ABC. So if it's equilateral, then we know that each angle is 60. Okay. So drop a perpendicular from here. So this angle is 60. This angle is 30 degrees. Now, if I call this one P? What is the relationship between length AP and PB? If these are perpendicular line AB, how are they related? AP and PB. Don't disappoint you from too much. How are these lengths related? Okay, now I think now it's going to be about how is AP and PB related. This is an equilateral triangle. So this is also 60. And then I have bisected this angle at 3. So is there a relationship between AP and PB? This distance. They're equal, okay? So this distance and this distance are equal. So let this distance AP be 1 unit, this be 1 unit. So which means from A to B, what the length? 2 units. Okay? So then obviously this will be 2, this will also be 2. Then from Pythagoras theorem, what is the value of length CP? Knowing that now we want to consider this triangle. So A, B, C. So what is the length CP? Root 3. Okay? So this is 1, this is 2, this is root 3. So then now from Moshachota we can define the other three trigonometric ratios of this triangle. That's tan of 60. So tan is tan 60 root 3, okay? And then sine 60, this triangle. Next thing from Kevin. What is sine of 60? From this triangle. 1 over sine. Don't use a point. 3 over 2 because sine is opposite of hypotenuse, okay? So with respect to this, so this is 3 over 2. So that's what we have. And what will be cosine of 60 degrees? What is adjacent of hypotenuse? Okay. Then now remember the other 3 trigonometric ratios that we have defined today. Cot will be the reciprocal of tan. Okay, you can always get it. Sine, the second is the reciprocal of cos, and cosecant is the reciprocal of sine. So you can always define it. And then what will be tan of 30 degrees? This triangle. Okay. The one. What is tan? NCB. 1 over. So tan opposite over adjacent. So it's the same as 3 over 3. Then next person, what is cosine of 30 degrees? So 3 over 2, correct? So 3 over 2. Then next, what is sine 30? Opposite over hypotenuse. So these are the things you know from your form 2. And then consider this other triangle. So believe that that's a right angle triangle at this point. So let this and this be equal, so that this is A, this is B, this is C. So this is 45, this is 45. So this 45 degrees, 5 degrees. Please believe that this is a isosceles triangle. So actually, this would be one. My sketch is wrong here. So if they are, if that this is for 5, this is for 5, then I expect. So this distance and this one and one are the same. So this 90 degrees. So this is what I have as P. This is C. This is A. So this and these are equal. 45. 5. So let this be 1 unit. This be 1 unit. So S will be next person. Approach 2. Hey, you have been given a easy question, so you'll have to be given the next. So I'll be able to room back to the theorem. So then now sine of 45 degrees. Gilbert. 1/2. So you same as 42/2. Then cos 45 degrees. 42/2 still. And then tan of 45 degrees, 1. And what will be cot of 45 degrees? Still 1, okay? Simple of 1 is just 1. So those are everything high school. So now let's now try this. So simplify the expression. Simplify the expression. Square root of sine power 4x plus 4 cos squared x minus square root of cos power 4x plus 4 sine squared x. So simplify that. Expression. I don't know the case of you try you have to see how you so try to see how you can play with these expressions under the root signs such that the root can cancel out. We are good at trying to see how you can divide this as a square to eliminate the root sign. What are you getting? Okay. 2 sine squared x minus 1. That's one answer. Anyone else? Any other answer? I'm not saying it's wrong. Yes? Just 3. Any other? Audio? Audio. Trust your answer. It may be different from this one. Maybe the right answer. Okay. Cosine of 2x, correct. And that's a correct answer. Maybe you please comment. Right.
So you can do you can say sine power 4 x sine squared x squared, which I can say is 1 minus cosine squared x squared, which squared is 1 minus 2 cosine squared x plus cosine 4 power x. But then if I add the 4 cosine squared x so now these two will simplify to become 1 plus 2 cosine squared x plus cosine power 4 of x, which can be rewritten as cosine squared x plus 1 squared. So now this, when you find it square root, it will give you cosine squared x with the cosine squared x plus 1. When you find it square root, you can do the same thing with the other bracket, and you'll get something similar. You get that cosine 4 cosine 4 power x plus 4 sine squared x. And when you find the square, which should be similar, you should find that using that same method, it will give you sine squared x plus 1 squared, which will just be sine squared x plus 1. So now when you combine, it will be cosine squared x plus 1 minus sine squared x plus 1. So now this becomes cosine squared x minus sine squared x. The ones have gone out. So now this you can simplify to be cosine of 2x.
A equals to B, then equals to A cos squared A minus. So this is what it is. final answer. Then the other one. The other question. Let f of x sub k be given by 1 over k into sine power kx plus cos power kx for k equals to 1, 2, 3, etc. Find exact value of f of x for minus f of x sub 6. So, is expression for all real numbers x. Please start by giving us the name. What's your name?
Alan.
Alan.
Alan. Hi.
Alan, the good.
Yes, Alan.
Yeah, Alan, okay.
Yeah. So the question was for f a x is equals to 1/k brackets 9 a x plus cos a x.
Yeah.
So to start off, we'll start with f for x is equals to 1/4 sine 4 x to the power 4 plus cos x power 4. So let's start by simplifying this. So we have let's start with sine squared x plus cos squared x is equals to 1. Square both sides. Sine x to the power 4 plus cos x to the power 4 plus 2 okay, 2 sine squared x cos squared x is equals to 1. And then you take this to the other side, you get 1 minus 2 sine squared x cos squared x, of which we remember that sine 2x is equals to 2 cos x sine x. So if you replace it, you get it is equals to 1 minus so you get 2 sine x cos squared x equals to 1. Take it to the other side, you get sine x to the power 4 plus cos 4 is equals to 1 minus 2 sine squared x was squared x. So now we have sine 2x squared is equals to 2 sine x plus x squared, which is equal to 4 sine x squared cos x squared. So clearly, this is a half cos squared 2x, right? Next thing. So for the next thing, we are going to try to find f6k, fx and k6, right? So it will be 1/6 sine 6x plus cos f6x is equal to 1/6 sine 6 that. So now we try to find a way we can manipulate what we have to get this, right? So we'll start with sine squared x plus cos squared x, and then times sine power 4 x plus cos power 4 x, like that. So we expand this so that you can get the terms sine x to the power 6 plus cos x to the power 6. So multiplying, you get sine x to the power 6 plus cos x to the power 6 plus sine squared cos 4x plus sine power 4 squared x. That. And then we notice that this is equals to 1, right? Sine squared x plus cos squared x is equals to 1. So basically, this is just equal to sine power 4x plus cos power 4x. Like that. Now, if we factor out this one, we have sine 6x plus cos 6x plus common terms, we have sine squared x cos squared x cos squared x plus sine squared x, and then of course is equals to sine power 4 sine to power 4x plus cos power 4x, like that. Going back, this is 1, right? So since this is 1, and we have this one, we have sine squared x cos squared x, and we had related that sine squared 2x is equals to cos sine squared x cos squared x. So basically, this is like saying it is a quarter sine 2x, sine squared 2x, right? So equals to sine 4x plus cos x minus a quarter sine 2x. That's then we had that sine to power 4x plus cos to power 4x is equals to where is it? Anyone remind me what we got? Sine to power 4x plus cos power 4x.
So we are not following. What is the standard?
Was 1 minus a half sine squared x, 2x. Like this, 1 minus a half sine squared 2x. So we come and replace 1 minus a half sine squared 2x minus quarter sine squared 2x. Then we get 1 minus 3/4 sine squared 2x. That. And now we can go on with the question. It is f(4)x minus f(6)x. That. So we come and replace b a quarter into brackets 1 minus a half sine squared x minus 1/6, 1 minus 3/4 sine squared 2x, like that. Then when we expand, we should get a quarter minus 8 sine squared 2x minus a 6 plus an 8 sine squared 2x. And then, of course, this one will cancel out. You remain with a quarter minus 6, which is 1. So, not like that. For me, what so because if okay, this is correct, the same answer anyway, but now with different people can yes. I don't know. Boy, is it 4:30? Or is it 2 wait, 4:30 or 5? Or what is the assuming we use the previous? Okay, okay. So what yeah, just yes, yes. Huh? 4:30. Good, fine. So Alan, for me, what this tower reason is out. So by definition, so if 4 is 1/4 into sine power 4x plus cos power 4x and then f6 is 1/6 sine power 6 plus cos power 6 x. And then you say this one from the odd powers of cosine and sine, then it actually tells us that probably we need to apply this Pythagorean identity. Because of the even powers of the sine and cosine. So then now, this sine power 4 and cos power 4, this bracket alone. So sine power 4 can be written as sine squared square, and then this is cos squared x square. So this is just this bracket alone. So then now remember a squared plus b squared is a plus b squared minus 2ab. Okay. So that now when I have a plus b will give me 1, because a will be
Sine squared, B will be cos squared. And then you can get that expression multiplied by 1/4. Similarly here, this is sine x power 6. So which can be written as sine squared x power 3. And then the other one will be cos squared power 3. So then tells us that this is an identity of this form. A cubed plus B cubed. So which you know that its factorization is A plus B A squared minus AB plus B squared. So this one. So when you do the substitution, we'll actually get the same thing. Actually, we'll end up with something of similar kind. So by just making use of this. But there are many ways of killing a rat. So that is good. So check that if you use this approach, still you get the same 1/2. Now let me give an easier one at least so that we don't struggle so much. Given that 1 plus tan 1 degrees multiplied by 1 plus tan 2 degrees multiplied by 1 plus tan of 3 degrees all the way multiplied by 1 plus tan of 45 degrees equals to 2 power n 5n. In fact, I'm very good-hearted. I should have not given you this energy. I've asked you to just find the value of this expression. But anyway, given that this product reduces to 2 power n, find the value of n. Find the value of n. But if you don't do it, so that is something that we can and that one is actually sound ready. So that is an end for me. So I will don't need just right now. The second problem will be find find the smallest positive integer n such that one over sine 45 times sine 46 plus one over sine 47 sine 48 plus other several terms plus one over sine 133 sine 134 is equals to 1 over sine n degrees. Let me give you a hint on this. Sine 1 over sine of x multiplied by sine x plus 1 is the same as cot x degrees minus cot x minus 1 degrees. Last problem. In a triangle, ABC, 3 sine A plus 4 cos B is equals to 6 and 4 sine B plus 3 cos A is equals to 1. So find the measure of angle C. So your tea break depends on these 3 problems. So but once you have one of the if you are still wanting one of the 3 problems, you will raise up your hand. Check. And if it's confusing, it doesn't have to be the right hand. It's confusing then it's in the board. Have something? There's one with there's someone with an under the first problem. So tell us the name of the school you're coming.
Yeah, I'm Abel. From? Friend.
Okay.
The problem is that 1 plus to find the 1 and 10. So first, I use the tangent identity, the double angle for tangent. Is that tan A minus B is equal to 1 minus tan A tan B over 1 plus tan A tan B.
So the numerator is tan A minus. Then when you are writing, ensure that you say turn into brackets A plus B, just to for it to complete. So it is tan of A minus B. So you need to put this back. You don't need to put the bracket in. So tan A minus tan B. Yeah, tan B.
This plus
That's right.
to I put out the fact these terms in difference to 45. So I had 1 plus tan for the first term 45 minus 44. Then 1 plus tan 45 minus 43. We have to 1 plus tan 45 minus 0 equals to 2 power n. So then tan 45 minus 44 is equivalent to Then this can be reduced to 1 minus tan 44 over 1 minus tan 44. So this here can be reduced to this. So adding the previous one, get this is equal to, if they cancel, it's 2. Is that okay? Then, so if this is true for all the terms, and we have 40, yeah.
To address myself. For him to get to. Things from, is this for this one or these two or first one? You are two pairs or one pair? Two brackets or one bracket? One bracket. Is it one or two? Let's see. This is 45 minus 44 and 45. Okay. And then this other one? Then so how we have for the last one? Bottom? So yeah, the top one. So then up to the previous bracket here. So what is the term here? So what is the before this 1 plus tan 45? Which bracket is it? So just close. Tan? Why 1?
Because
Okay, so this is the function 1 plus 1 plus 3, then all the way to 1 tan. So what is the bracket? Tan 44. What is that? So 1 degree can be 44 can be. For that minus 1. Okay. So then when you this so we think that the denominator is 1 plus yeah, I think this is our because you see, yeah, so what's yeah, this is the plus. This minus this minus this is the plus. So they're not just So with the two is the two comes out clearly from bracket. Along the other. And actually the answer, but then just one thing. But it's something that goes to the trial. Who can finish it up? Who can finish it up? That's a good trial. This is your then find it out. So then they find the last bracket is and then you will play with this other bracket. 1 plus 1 up to 1 to 3 something. How you can relate it? The values we are defining, they are terms, so that there's an element of because we are finding that. But we are able to break that. So who can finish up that explanation? It's good that you are saying that for place. The answer is also take out when being the same how to play and what's happening here? That's the question. Maybe we'll come on. Yeah. So tell us your name and we.
Yes. My name is Muteti from the Nairobi school.
The Nairobi school. So
Okay. My argument was that
take the pen first. Take the pen.
notice that we can create a pair 1 plus 1 and 1 plus 44 for each of the terms in the sequence. So we can have 1 plus 2, 1 plus 53. So I concluded that if, for example, we were to have such a pair for 1 plus 0, 1 plus 55, it would be, because times 0 is 0, this would be 1 times 55 is 1, so 2. This would be 2. It follows that the other pairs would also give us 2. Yes, so that was my argument. Not very convincing, but that's what I think. There are 22 pairs because yes, here there are 22 pairs. Here there are 22 pairs. This is, yeah, this is. So I concluded 2 raised to 23.
Okay. Good. Fine. So I have the same argument. Now this is how we are. This is what we can have. So turn. So if we have just a general expression, say 1 plus tan k into 1 plus tan of 45 minus k. So reason that's why we are using basis of argument, because we know that tan of 45 is actually 45 is a special. So if you were to have such a pair, then when I multiply, I'll have 1 plus tan of 45 minus k, and then plus tan k, and then plus tan k multiplied by tan of 45 minus k. So that is the expansion of the pairs of such. So then I can write this as 1 plus, then I can have tan k, then plus tan of 45 minus k, and then plus tan k. Okay. Tan of 45 minus k. So that's just rearranging the sample. So want to see how the simplification of apply to the test angle of discussion. So then I can force this term. I can force this term. I can force this term of this nature into this bracket by saying this is the same as 1 plus tan k. So what should be my first bracket if I put k outside? This is not actually 45. But okay, I can have this. Is it 45 or k? Yes. Let me have this. So I have this 1 plus into tan k plus tan of 45 minus k, and then plus tan k tan k tan of 45 minus k. Is that correct expansion? You open that? That will come in. So then now I can write this one as one plus tan of 45 degrees into tan K plus tan of 45 there's this term I'm not so tan so tan or check if the simplification of that expression 45 into 1 plus tan K tan 45 minus K and then close brackets plus tan of K and then tan 35 minus K. I don't need that one. Any other questions? On the previous one? So confirming that resistance, so that this will give you 1 plus 1 to give you 2. Just check whether that one is confusing. I'm not sure. So check how we can play with this these terms involving 45 minus K and tan K to produce. It actually give it will actually help you convince the ways. But when now you get the pairs such that this value of tan plus the value here of tan, the total should be 45. And then from 1 to 45, there are 45 brackets. But then brackets which will give to will be pairs where this value first number plus the second number is 45. So the last bracket, which is 1 plus tan of 45, is actually is 2 by default because this one are 1. So the 44 terms remaining, 44 brackets remaining when so 22 plus 1 is 23. So please take argument. Still, there's another solution, but we can take that one. So try the remaining two problems. Try the remaining two problems and let's see the argument. So maybe I can provide the answers so that maybe check it. So the other. So number 3, in a triangle, ABC, the mesh of C is 30 degrees. So check that the mesh of C is 30 degrees. And then the other one. And the trick, actually, the trick in the triangle ABC, square the two equations and add them. So the trick for number 3, square the two equations, then add the result. You'll actually see where the 30 degrees is coming from. So you'll have a place where you'll be applying the property of the Pythagorean trigonometric identity. And then the other number 5, check that the answer should reduce to 1. The smallest value of n is 1. Check that such n is 1. So we can stop there and then meet in the evening to continue the discussion.